spinning up. Okay, there we go. Everything is running up. Okay. So we're going to work on inclusive rectangle logic for rectangles that we want to manipulate and sync with the GPU. So we want some type of way to have a viewport that we can kind of like move around and zoom in and out of. The way we're going to do that is we're going to use an inclusive rectangle to view over the region of the tile map that we want to zoom into. So we're going to solve everything kind of very geometrically, right? Instead of having like a camera X position and then just moving around a camera that's kind of like centered on whatever that X position is, we are literally going to, have a camera that has 4 points. It needs a lower X boundary, an upper X boundary, a lower Y boundary, and an upper Y boundary, right? So those are the points that you need to define a rectangular region. And that's what we'll actually use to when we're manipulating our camera. We're not going to just say, oh, camera.x over here, camera.y over here. We're going to move all 4 points. The reason for this is it's just easier to visualize what's actually going on when the camera is like that. And I want to do the code in a way that the camera logic can be very compatible with the way I'm trying to do my rendering algorithm. With that out of the way, let's see what we got to do here. So in TAUTYPE, we want different types that are on the texture as uniform. And one of them is going to be a rectangle. So let's do an inclusive rectangle. Inclusive rectangle. This will be our inclusive rectangle code. And within here, we'll say, I guess technically it's going to be a void AAC 2020 tau type, and then we'll call it rec inc for inclusive rectangle. Yep, rectangle inclusive. If we did inclusive rectangle like this, I believe it is a mistake, and it'll tell me. So let me just check. Yeah, it's backwards. So rec inc, and we need some basic like commands for this. For what we're going to do with this inclusive rectangle type. So I see someone's just joined me. Right now we are manipulating a rectangle type that exists on the GPU memory, or technically it also exists on a CPU side allocation. But basically we're manipulating a rectangle type that just exists within the pixels of a bitmap. If that, that might not be the best one-liner explanation of what's going on, but that's what I can give you right now. So rectangle inclusive, and we need something for zoom in, zoom out, and I want to keep the number of functions pretty low, so really all we need is a function that's going to like zoom in, zoom out, and then another function that is for translation, right? So let's call it like a, I swear I had some names for this that I was going to call them. Let's check our agenda screen here, see if I had made anything up here. Nope, we don't have a name here. Did we do anything in our notes here? Nope, we didn't do anything in our notes. I swear I was meticulously trying to come up with a name. I guess we'll just have to call it, zoom, and how about call it zoom out, and well, let's think about this. So we could have a zoom out and a zoom in, and then a zoom out could end up being a zoom in, depending on if it's given a negative or positive value. So when we think about a zoom function, do we assume that a larger value is zooming in and a negative value is zooming out? Or do we assume the other way around? I think when we think about increasing a zoom, right? When we think of a zoom factor, we think about adding values. So I think we'll do that. Okay, yeah. So we'll call it zoom. And to zoom into something, we have to pull the rectangle in. So I'm going to call it zoom pull. Because we're actually literally going to take the borders of the rectangle and we're going to pull them in, right? And if we want a push, we're actually just going to call this with negative values. Okay, so also let's look at the TAUTYPE here. So this guy right here. And we want to look at its functions. So usually I have functions on the right and then the data on the left. But we want to look at both of these functions right now. So these kind of get input functions are going to be used. We want to keep the same kind of interface. So it's kind of weird. But we want to keep like this signature right here. And for these values, we don't care about these values. We actually want to manipulate the data on the bitmap without ever getting any of the values back. You know, we could have something here for some type of status about like how much do we end up zooming in, some type of value that we could use in a test maybe, but really we only need these guys here. So this is what we need. And we're going to have to change what this is here, right? This is not an acceptable signature, but they're an example, right? So they're example values. So we're going to go like this. We're going to take this, and I know we've been pretty inconsistent with what we name these variables. We like call them dex whatever, or sometimes we call them like tau 015. If you want to be like nice and verbose about it, then if you want to be verbose about it and also be proper about it, then we can't make it all uppercase, because that would be more of a define, right? Defines are all uppercase, so let's keep these parameters lowercase. And I can kind of see why I eliminated dex from the variable names that I've been using, just because dex is a very, like, it's a very redundant name. So we could say, you know, index, and then tau sub and var, example, right? And then that stuff, right? And then we could do here, let's do that. So, and also this needs to be indented like this. So just like this kind of naming here. And then we'll do, how about we call these ints? Well, let me think about it. These indices, a UO8 should be fine. And I know we've been getting bitten a lot by, you know, using data types that have a limited number of bits, because we keep on integer overflowing when we make mistakes. But I don't know, there's something I like about just using only the number of bits that I actually need. And maybe that's ill-founded, maybe that's just like some type of like psychological thing that I like. Oh god, I'm not even back on the, sorry, so over here, so I didn't even show you what I was doing. So right here on this side, we're just writing this signature, and we need to manipulate a rectangle type that exists only on the canvas. And I see somebody else just showed up. If you want to see what I'm kind of working towards, I can show you a quick demo. In fact, you know what? I'll just keep on dropping demos in the chat. That way it doesn't distract from the coding. And if you want to take a look at the kind of tech that I work on, it's right there in the in that URL. That URL might take a while to spin up because it's on a Heroku server. So if it's the first time it's been visited today, it's going to take a while to get for it to load up, because the servers go into hibernation. Okay, so we have this rectangle type, and it exists on that 512 by 512 bitmap that we sync with the GPU. And it exists as, the rectangle exists as 4 pixels located somewhere on the bitmap. And we want the signature of this rectangle operation to match these operations here. So in TAUTYPE, we have a put and a get command, and we want the signature to very closely match this. So these first three variables that locate the exact position on that, that canvas, that bitmap, where the variable is physically stored, where the pixels physically are, those pixels that represent the variable, we want these three parameters inputted as the first arguments to this function. And then when we're zooming and pulling, we want to say, well, by what amount do we want to like zoom in and out? And we could, you know, give a like an x and a y and a z kind of value, but let's think about the most common use case, and because we don't want to get too granular with this, because in the last code base that I did this, like I've already written this kind of code before, in the last code base I did this, I got way too granular. So let's not get too granular. And that's the reason why we're going to call this zoom pull. We're not going to have a zoom push. The idea is that to zoom, we take the corners of the rectangle and we kind of pull them in. And in fact, let's kind of like draw like let's have some fun here. This is TAUTYPE.f and this is TAUTYPE.d. We've been in the habit of drawing nice little diagrams. So let's kind of draw a little rectangle and kind of explain what's going on here. And I think that we need kind of like, if we really want to do this right, we need to have a few rectangles. Like, we need like 3 rectangles that are kind of like inside of each other to demonstrate what is happening, right? To correlate the command names with the actions that are actually happening to the shapes, right? Because the camera, in essence, is just a rectangle, right? And that's the way, do I want it like this? That actually looks more aligned, but then it's not. I don't know. Oh, that's because we gotta space that out better. Okay, so let's just draw like a little rectangle. And obviously, you know, little diagrams like this, they take time to do. Oh, I see why it was like that. Little diagrams like this, they take time to do, but the benefit is that we have a good mental understanding of what's actually going on. So, I guess if we go if we want 2 lines, then we're going to have to go down here like this, aren't we? Okay. You know, this font, that doesn't quite seem right. Let me change the font here. Okay, so settings and I believe preferences. Either preferences or style configurator. You think that after using this editor for like almost 15 years, I would get the difference between preferences and style configurator, but they seem like the same concept to me for some reason, so I always have a problem with that. So we're using Monaco, which is a great programmer font, but we're going to go use something like maybe Andale Mono or Anonymous Pro, which are also great fonts. Let's try Anonymous Pro. This is what we've been using in our OBS. Oh god, that looks worse. So we want something that has, like, diagonals. Let's see. Style configurator. So if it's not Anonymous Pro, how about Andale Mono? Nope. Okay, so Monaco, huh? So settings, style configurator, and I guess we're going back to Monaco, because the grass looked greener on the other side, but it turns out that Monaco is kind of the winner for these kind of ASCII diagrams. So save and close. Yeah, I mean, it's not the best, but it'll do. So, let's just try to get a nice little diagram going here. And, you know, whatever looks correct, I guess. And try to we're going to try to space everything out correctly as well. So, we might want to just do some dashes. 1, 2, 1, 2, dash, 1, 2. I think that odd numbers might make more sense with this. Kind of do this. And then over here. And obviously this is, you know, not quite coding, so if you were expecting code and then you see me just twiddling little ASCII diagrams, I could understand you being upset, so I'm not gonna be mad if you leave. Because I understand maybe you were looking for code, and here I am, like, twiddling away with, like, little ASCII diagrams, and you're thinking to yourself, like, what the hell is this person doing, right? Because, is this an efficient use of time to, like, make these little diagrams? And I would say that it is actually an efficient use of time. because the amount of times that we, so if we look at like TAUTYPE, the data, so not this, but if we look at TAUTYPE's data, right, like these diagrams that we wrote, we were looking at these diagrams almost constantly when we were writing all of the tree traversal code, right? We were like looking at these all the time. So, so it is a good investment if you have some type of concept that you need like a really good mental map of, to just take the time and draw a diagram for it. Now, other people might be like, well, yeah, you can draw a diagram for it, but, you know, why do it in ASCII? Because, you know, it's just it's a pain in the ass, and you're kind of limited in what you can do, right? Whereas if you did like a SVG or a bitmap, you know, you'd be better off. The thing is by doing it in ASCII, it's kind of a lightweight diagram. It doesn't take up too much room in terms of disk space, which I really like. Okay, so now we have these rectangles. Well, it's almost done. We gotta mirror this. So let's take this kind of shape here that we got, and let's take this, paste it like that. Alright, and then let's do the same thing over here. Oh, nope, not like that. Let's take, like, this guy, right? This one right here. So now we want to just get some type of... We also want to be able to, like, measure things out when we're looking at the diagram. We want to have an idea of where we are. And some of that might be kind of inconsequential for this specific diagram. But we're going to do it anyway. So we're going to take this, and then we're going to do this command called... it is just my command for my shortcuts, mirror text x. So we can just quickly kind of mirror, oh, this is, wait, no, mirror text x, that should have been right, mirror text x. Did it just collapse on itself? Looks like it. So sometimes I have to do this, I gotta like take characters like this and kind of make a little divider like that before I can mirror it properly. So mirror text, and now try x. There we go. Okay, so now that we have kind of two sides of the diagram, we can take this side right here, and we can kind of paste it right here, glue it onto this side here, and then we have something symmetrical, right? And now that we have something symmetrical here, we can work on the other side, right? So we can take all of this nonsense, and we can do mirror text y, mirror text y, and then bam. Okay, so now the next part is we have like this kind of spacing here, and we want to get that kind of same spacing. And it looks like for our rectangles, we're kind of doing like 3 OR symbols, and then after 3 OR symbols, it's a plus symbol, right? So if we have that kind of correct, then this should look about correct for the width. Yeah, that looks about correct. So it's gonna be kind of tedious because we're gonna hack this. We're hacking this together, right? Piece by piece. All right, that looks good there. And then we need to just kind of repeat that, right? So we're gonna take, it's 3 of them. Okay, so this is the middle, right? Okay, and then right here, I just gotta duplicate this. Actually, duplicate this line like that. Okay, there we go. We got a nice little camera diagram here. So the thing here is, it's a little bit noisy in terms of being a diagram here. I think that we should remove these 3 these things here. We want to make sure that we can kind of see the 3 rectangles that are. Oh, hey, yeah. Yeah, thank you. Yeah, Merry Christmas to you, too. I'm guessing it's horrible up there. I'm guessing it's, like, horribly snowy right now. But, yeah, right now I'm drawing some diagrams. And, oh, I put the code base. So there's not, unless you have Windows 10 64-bit, the code's not going to compile. But, if you see this git-AAC, tinyurl.com, git-AAC in the bottom right-hand corner. That is the code base. So I made a license for the code base. So if we go into the code base really quick, so I can show you what I did, and you're gonna think this is crazy and insane because, you know, I am a little bit insane, right? because who does this? Who just, you know. But anyways, let's show you what I got. So I made a license, and I think it's pretty simple. Well, it's not. It's simple in some ways, complex in other ways. So what do we owe for using this engine? So you owe nothing if it's less than 100,000 copies sold. Every copy after 100,000, you owe 1/4 ounce of instant coffee. So because of inflation, like let's say the currency hyperinflates, and we want like some type of royalty for this code base, I've decided that if you sell more than 100,000 games with this engine, for each copy after the 100,000th, you just owe 1/4 ounce of instant coffee, or the equivalent dollar amount, right? And then there's details for what these all capital things mean in the bottom of the file. So other requirements for engine use: do not remove the engine splash screen. So just a screen that says, you know, the makers of the engine, right? So Unity does this. They have a little splash screen. I don't know exactly what it says, but it, you know, advertises the engine that it was made in, right? The other thing is you got to sell your game for at least 32 ounces of instant coffee, which is roughly. It's not that snowy. Ah, well, that's surprising. Hashtag global warming, maybe. So actually, it's been ever since I was a little kid. Like every year has been getting like warmer and warmer. And it's been a consistent pattern, even in, like, Seattle. And I shall get that, and yeah. So, anyways, going through this little, contract, I guess you could say, or the license, you gotta sell the game for at least 32 ounces of instant coffee. That's roughly, $16 if you look at, like, the Folgers brand. But, like, if you can find a brand of instant coffee and do the math and find out that you get something cheaper than that, then that's okay, unless you get cheaper than a certain amount. So there is a bottom floor I added for these definitions, just in case somehow, if somehow coffee becomes, you know, as cheap as water in the future, I want some way to base the prices in something that's adjusted for inflation, right? So this weirdness of like basing the prices in terms of coffee is just my fun way of saying of adjusting things for inflation, right? So we have a little note of why dictate how much I sell my game for, and we'll get into that. Include in the root of installation folder coffee license photo. So in the root of your installation of your game, I want you to include just a photo of whatever brand of coffee you're kind of like basing the license on. So like if you found some Folgers at the supermarket and it was like $5 for 5 ounces, then that would be $1 per ounce of coffee, and that would be like how you would figure out what these calculations are. If that's the calculation, then 32 ounces of instant coffee means $32. If you can find the coffee for half that price, then your bottom price for how much you need to sell your game for would be like $16, right? So coffee license photo is just going to be a photo of whatever coffee you found, whether it be Starbucks or wherever you want to, you know, take it from. So then we have some terms like, okay, well, what is 1/4 ounce of instant coffee? So that is the cost of 1/4 ounce of instant coffee before tax, shipping, and handling. Oh yeah, I know you got horrible service. Like when I used to call my dad when I was at Nine Nights working at stuff, and then I would ask for like help for programming help that I couldn't Google. Yeah. This price is not allowed to be calculated using bulk factory prices. If you found a price at Amazon.com, Walmart, Meijer, or another online retailer, that price is suitable. If you found that price in an actual grocery store or coffee shop, that price is also suitable. The price cannot be below 10 cents, so if coffee somehow becomes as cheap as water, just give it 10 cents per copy of your game sold. Okay, so now there is a reason for, you know, having, you know, exact values rather than having like percentage royalties. First of all, it makes it easier for me to calculate. And second of all, right, we have a base value that I want you to sell your game for to reduce the amount of shovelware that could be made with this engine. Engine splash screen, just stating that this engine does not currently have a splash screen, so it's okay if you're currently using the engine and there's no splash screen. That's not your fault. It's just don't like intentionally remove the splash screen. Okay, so 32 ounces of instant coffee, pretty much the same, very similar definition as 1/4 ounce of instant coffee, but just talking about how you get that calculation. And once you figure out that dollar amount for what 32 ounces of instant coffee comes down to, then there's a floor price. So the price must be at least 40 cents per ounce. And that's so... that's just so... If, once again, if coffee becomes as cheap as water or whatnot, then it's not like this becomes zero. So the idea is just to keep things from becoming zero. So I was thinking about like hard coding dollar amounts into this, but let's say worst case scenario, let's say worst case apocalyptic scenario, let's say the dollar hyperinflates, and now our dollar is kind of like a Zimbabwe dollar, where you have like, people are walking around with $1 trillion notes. Well then, if that's the case, and we just did everything in terms of dollars, then the contract is kind of meaningless, right? Because it's like, oh man, somebody's just sold 1 million copies of a game with my engine. Guess they owe me a penny now, you know? So I just wanted something like that. Coffee license photo, right? Just taking a screenshot of, you know, whatever coffee you found that you're going to base the amount you owe for using the engine, right? So it's all very kind of silly and ridiculous. And then we label this kanji coder coffee license version 1. And you know what? Even though it's silly and ridiculous, I don't think it's too crazy. I don't think it's too... I don't think I'm asking too much. And then even if I'm asking a little bit too much, well, you don't even have to worry about it until, you know, after you've sold 100,000 copies of your game. So it's like, basically... you can look at it and you can be like, oh man, that seems like a little bit too much effort, but it's not an unreasonable amount of effort, and nothing's stopping you right now from using the engine, right? Because 100,000 copies. Okay. So anyways, we're drawing like little diagrams here just to be able to visualize what we're talking about when we are manipulating the rectangle that is going to be used for our camera, right? So we're going to actually use, we're going to solve everything very geometrically. So the camera does not have a center point. Unlike, I mean, I guess you could technically derive a center point, but in our math for the camera, we're never going to be using, center points. And that kind of looks a little bit odd. Let's make those little dots, or maybe pluses. Yeah, there's never going to be a camera center point, because the camera is defined by this point here, this point here, this point here, and this point here. And let's just do this. Okay. And what are we missing here? So yeah, it's going to be kind of, a lot of this is kind of tedious, but it's my experience that these diagrams very often save my ass when I am trying to code something and I need to look at something really quick. And like I said, we could do something in MS Paint or whatnot, but the nice thing is having everything in the same format, right? You open up the code base, and as long as you have a text editor, you can see everything, right? Like all the documentation, even all the visuals are done in ASCII, just because it just makes it so much easier to develop with this, right? So you don't need like a super fancy setup to understand my code, to use the documentation, because everything is very rudimentary, and that is by design. I am kind of a pocket knife person as opposed to somebody who would use a blender. So like in a kitchen, all I really want is like one nice sharp knife and like a cutting board and like a cast iron pan. I don't want like a whole bunch of fancy stuff, and I'm the same way with my code. And if you're following along because you like C code, then you're probably in the same kind of like mindset as me, because I think that C programmers kind of have that mentality, and a lot of times what brings people to a certain programming language is the culture that surrounds that language, right? Like what do people who program in this language, how do they tend to think, right? And that's obviously a big generalization, but I think it is very true that different programming languages have different cultures, and like a good example is the main reason I hate Java is because people are, you know, like wrapping everything in getters and setters, and I absolutely hate that. And there's no requirement when you write Java code that you have to write Java code that way. But I guarantee that if you do write Java code to, you know, as a professional in like at a business, that you're going to get stuck writing that kind of Java code, right? And so it's not really just the language that can be a point of contention. Like, it could just be the culture around that language. So, do I hate Java? Yeah, I'm pretty sure I hate Java. But if I were skeptical about if I hated Java or not, it could be that I just don't like the culture around Java, right? And I've seen similar things with data-oriented design talks with surrounding. There's this guy who gives this data-oriented design talk about like programming games, and he's like, if I had my choice, I would do everything in C, but we got to do C++ because all the programmers, they know C++, that's what they know. But he doesn't like the culture around C++ because it's not as friendly towards his kind of data-oriented design principles. Okay, so that looks pretty nice. And so what we got here is we have, you know, 3 concentric rectangles, and I just want to diagram out what we mean by zoom pull, right? So, so let's say this is, you know, this is zoom pull, something, 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 and then, let's just say, when we zoom, we're going to assume that zooming with a positive value actually brings you in, right? That's why it's called zoom and pull, because we're pulling in that rectangle. So, we'll say, you know, a +1 right here. And that will kind of denote that in this area, it's zoom pull +1. And then in here, oops, hold on. And then over here, we're going to do the same thing. It's going to be zoom pull. This is +0. And we might as well try to align this nicely. It looks like there's no way we can really do that unless we kind of like add a little space here, go back here like that. That's fine, yeah. Okay, so this is zoom pull +0, and then this rectangle up here is zoom pull, and this is -1. And we might want to make a little line here when we're trying to like point to these things. Yeah, we should probably put this closer, now that I think. We should probably put it closer to up here, right? We should probably put it up here so that it's kind of connected to the edge that we're talking about. And same thing with this. We should probably put this up near the edge so that we don't get confused about what rectangle we're talking about, right? So we're just trying to identify the transformations that the functions do and how they affect the rectangular region, right? So zoom pull. Okay, so zoom pull +1 is going to bring you from... So if zoom pull +0, here's your base rectangle. If you zoom in, you're going to end up here. And then if you zoom out, right, zooming out, you're going to use a negative number, and then the rectangle gets enlarged, right? And it's going to pull in and out equally on all sides. And we're also going to make it so the default function, if you try to get too large on any one axis, the command just doesn't work. The alternative is to like clamp the sides individually, but then what will happen is if you zoom, let's say that the camera rectangle hits the bounds of the level on the X before it hits the bounds of the level on the Y. So you clamp the X, but you don't clamp the Y. when it starts to get too large, and then the camera starts to skewer, right? It starts to stretch upwards. We don't want that. So if any of the boundaries are hit when the camera is zooming in, we'll just stop zooming in, or we'll readjust the camera position to make up for that. Like if we're zooming in and we're in the corner of a level and we can't zoom past that, then we'll kind of move the camera over a bit to account for that. So this is obviously a large comment, so the next thing you want to do is kind of write some comments around here. And just because, you know, it's otherwise it's not a valid C file anymore if this isn't inside of a comment. The thing, though, is I realized that it's either these backslashes or the forward slashes. One or the other is actually going to cause this to compile incorrectly with a multi-line comment. I don't know why. Oh, it could be... Actually, that could also happen with single-line comments, too. So we're going to get rid of the diagonal lines. And the diagonal lines don't look that good anyways, depending on what we're drawing this with. So we're just going to replace anywhere we see a diagonal. We're just going to... That's a little bit wonky, but yeah, it's I think it's the backslashes that cause a problem, because it's a line continuation character, and I'd rather just not risk it right now. They may be okay in the diagram, but if you get errors from having characters that shouldn't be in your comments, which is kind of weird because you think that it's a comment, so nothing should ever happen to it. But yeah, for some reason, these characters in comments just do weird things. So let's do this. So zoom pull, and that's good enough for me to understand what this does. You know, it's a pretty basic concept, right, of what's happening. But if we want to look at this, you know, once we look at this diagram, it's kind of obvious what's going on. Okay, so we're going to have to look at the TAUTYPE data, or not the data, but the functions. TAUTYPE function. So we want the signature to be like this, because, you know, we're going to actually be using these. So let's see, zoom pull. The first thing we want to do is we want to get those values. So it's going to be U32. Like, all these values are going to be U32 values. And also, these need to be U08s. Okay, and U32 x0 equals, and let's just do FF, 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 FF. So this is just a trap value. Like, we need to assign it to something, but in case we forget to assign it, we're just going to max it out and then hope that we notice that it's one of these maxed out values and know where the error is coming from. So x's, then y's, and then zeros and ones, right? Okay. So we'll take this get command right here. We can just kind of paste it right here from the documentation. And we want to replace it with these variables here. And we don't really need to take up this much room. We could split this over multiple lines if we wanted to, but it's already formatted this way, so I don't see any reason to change the formatting. Though it is kind of bulky, right, with the way we've kept this function, so it's like, I don't know. Jonathan Blow, who does the game Braid, who did the game Braid, and I don't know who he's working on now, would say that I'm being stupid for writing it this way. Or I don't know if he would say that verbatim. Let's not misquote him. But I think he said something along the lines of, you know, I don't know what he said. It was some type of pejorative. I don't know exactly what it is, but he's not a fan of doing this, right? Like, putting every single variable on a different line. But depending on what I'm looking at, I kind of like every single variable to be on one line, especially because now I can cut and paste this over to here if I need to do that. Okay, so now that we're getting these values, right, because we have these ands, right, so we're returning the values by reference, and that's why we're passing in pointers to these variables. Now with these variables, we want to do the correct math. So it's zoom pull, meaning that when we pull, we're going to pull in the rectangle, right? So let's say that, let's just do the basic math, and then we'll kind of fix it up later, right? Because there's going to be some mistakes with how things need to be calculated. So to pull in the left boundary, we're going to have to add the zoom amount, right? And we did not actually add that, so let's do that now. So our camera is going to be in terms of pixels. Yeah, we're going to keep everything measured in pixels. And I don't know if that's is that the best way to think of it? I mean, there's other base unit that we could use, but I think for now, the base unit being a pixel makes sense. However, we did have another unit that we wanted to use for a different kind of shader. Now, pixels is pretty straightforward. So when you're zooming in the camera is kind of like this rectangle overlaid over the data. And or maybe not. Let me think about this. So, let me look at I have like a folder where I put some other code that I was working on, some math. Like I was working on some math for some other calculations for another shader. And I have some math for that. So, SDF folder. If I do SDF folder, can I find... so I have the old GLSL shader code tutorials I was working on. I had some diagrams somewhere in all of this somewhere. And I don't know where that would be. I guess it would probably be in common or here. Let's try common and see if we can find any like little diagrams. No diagrams here. Let's try this right here. Let's see if we can find some diagrams here. Do you have any nice diagrams? Oh, there's some diagrams. Yeah, so here's a thing. Where am I multiplying everything together to? Oh, these are some diagrams. So this fractal auto-tiling nesting kind of thing here, I think I want to take some of this stuff and paste it into the current code base. Extracted comments. Yeah, so right here I was trying to find a base unit for a shader. And I was thinking, well, if we're zooming in a certain amount at each level, we don't want to lose precision with the numbers we're using, right? Like floating point has only so much precision, so how much of the math can be done in just raw integer values, right? And I was trying to figure out that value, and I think the calculation should be here. Yeah, this number right here is like my value for that. Now, I don't know how the camera would work if we use that kind of value for the shader math, though. I think this is a good thing. I think we're gonna keep this in. We're gonna take this whole thing here and set extracted comments. We're going to we're going to take this whole section from this old code base and yeah, we're going to take this and just throw this into our notes file because I think it's important. And Yeah, let's, yeah, I think that's kind of important. So let's take this and just say, SDF, patent, shader, plank, units, or something like that. I don't know what to call it exactly. Because these diagrams will be kind of useful for when I'm trying to reason about precision and whatnot, even though it's kind of meta here. Yeah, that's fine. It's all nicely, it's already nicely aligned. And, you know, while we're at it, we might as well say, you know, do we really want to take... We don't really need these variable names here, do we? I don't think these variable names are going to be referenced anywhere in any of these diagrams. Oh, actually they are, aren't they? CSC. Is CSC here? Yeah, so we do kind of use these variables in the diagrams. So let's just take, extracted comments. 16 floors of each color. Yeah, where's my 16 floors of each color thing? So I also have a commentary where I did like 16 floors of each color. I'd like to know where that is as well. So I want to just find all the nice little diagrams that I've been kind of doing. And, we'll worry about... So this is the key. Yeah, but we want to just consolidate some of the other kind of diagrams and things we were doing when we were doing some other work on some other shader stuff, because some of these diagrams are actually going to come in handy, and we're just gonna kind of throw it in here, right? We're just gonna kind of throw it in there willy-nilly, and so SDF. So I'll just make a note that this is extracted from, and then RGSDF 2020 slash SDF019 dot underscore. So I just want to make a note where that's extracted from. And I know I have some other nice little diagrams. Let's just open up every file, make sure that there's no diagrams in them. But I think that it was mostly in that file that had those diagrams. And there's more diagrams we actually have to find. Because I know we did like a whole bunch of complicated math for this. I don't know where that is. Oh, I think the math itself was... Oh yeah, this is our floors kind of a thing here. Okay, yeah, so this is the diagram I actually want. I don't think any of the other diagrams are necessary. Let's just see if there's any other diagrams in some of this code that came later. And if there is no diagrams, or just a quick little look through, I'm not going to worry too much, because this is for a different shading engine. But any like really valuable diagrams I'm gonna take. Doesn't look like we have anything. So 16. Yeah, I don't want these diagrams. No, that was just the... Right, it's like when you took a lot of time to think about something and you wrote really complicated notes. It's like, you don't want to waste those, right? Like, right, like a diagram like this kind of like took a long time to figure out. So we could make a note of that as well. So this is for, hello. How's it going?
Take a break.
So, no. Hasn't even been an hour. What's going on?
Gramps has an opinion on what you should be doing with your time.
Uh-huh. What does he want me to do?
Get a job.
I see. Okay.
And I wanted to deliver the news potentially before that conversation happened.
All right.
So.
All right.
All right. Goodbye.
All right. See ya.
I like you.
I like you too.
Can't kiss you.
All right. So. All right, let's take this and let's paste it into. Gramps thinks I should go get a job. So let's take this and paste this over here. And just make a note of what this is from as well. So let's do... this is from... What was this from? SDF 13. So let's just say SDF... we put zeros before it, right? SDF 13. And then we'll do this here, right? So taken from SDF 13, like that. And yeah, that's good there. Okay, so that was a little distraction, but so the zoom amount, we want to, for the left side, right, if we're looking at the left side here, let's look at this here. So the left side needs to be, this right here is, this is x0 right here. If we're looking at the main rectangle, right, we're looking at the rectangle before it's been changed, then this is x0, this is x1, and then up here is going to be y0, and then down here is going to be y1, right, like y1 like that, so y0 and y1, okay, and okay, so now what we're going to do is kind of add the offsets, right? So x0, we want to pull it in, so we got to minus the zoom amount, and I don't know what we're going to call the zoom. I guess the zoom amount is it should be a U32, so we could just call it zoom U32, right? Just so that we know that it can't exceed certain values, I guess. And then we will, you know, paste this here like that, and make sure that the opposite is the opposite sign, right? So we're gonna move the left side in towards the right. The right side, right here, is gonna move in the opposite direction. Hold on, did I get that backwards? Well, hold on. First of all, let's do this. Maybe I did get this backwards. Did I get this backwards? Yeah, I got that completely backwards, right? Because this thing needs to move in this direction to get it pulled in, right? And right when we use a positive value, we want it to zoom in. And in order to zoom in, we have to make the rectangle smaller than it was before, right? So this actually has to be plus, and then it's plus minus, right? So plus minus and plus minus, okay? So x0 and all that. Okay, so now that we have this, the next thing we need to do is think about how do these values need to be capped? And I really don't know what that needs to be right now. So I think for now it would be good to just keep them like this, and we also need to think about the initial values of the rectangle as well, right? So when the game boots up, how are we going to set this rectangular region? And we don't know. We don't actually have an initial value set for these rectangles. And if we don't set an initial value for the rectangles, the viewport could start out really small, probably up in the corner, right? It gets if it gets 0 initialized, right, it'll be up in the corner of the screen, infinitely small, well, 1 pixel small, right? Because it's an inclusive rectangle, so the smallest the camera can ever get, the camera rectangle, it can be 1 by 1 pixels. But we might need to think about that. So what we'll do here is we'll just do like a AAC 2020 vital to do. Actually, no, AAC 2020 to do manager vital. And we'll just say to do camera initial size, right? We need to make sure we know what an initial size for the camera is, right? And the next thing we need to do is we need a translate command, right? So we got this zoom pull, which is going to, you know, it's zoom, right? And, well, also we might want to do something like this. We might want to do a, up here, we might want like void AAC 2020 tau type rec inc zoom push, and then say we're not actually going to make it a command. We just want to make it so that, you know, we're just say error, do not use this, use zoom pull, right? So just make a note of what we don't do, right? It's what we don't do is also important. It's as important as what we do. So we're gonna say that if you try to do the opposite of pull, you try to do like a zoom push, that's actually going to be an error. And then we need like the macros and whatnot for the error functions, but we don't have an error function here yet, so we have to say that halt is typically the first function, right? And 489 paste, right? So 489 paste, right? And that can't even be a valid error code because it's over 255. So I didn't know what I was thinking when I did that. I think I was just being silly. Let's just do, I don't know, 202, doesn't really matter. And then the correct namespace. So tau type and then halt. And then over here we'll do tau type. And this really should be lowercase, so AAC 2020. And so the error message, we'll print it out. We'll also label it that it's a fatal error, what system it's coming from. We'll flush the output to make sure we see the message before the program exits, and then we'll exit with code 202. Any code that is not 0 is a failure code. We don't really care what the specific failure code is. We just care that we kind of see this message when it crashes. So now that we have that, the next thing we want to do is we want to translate the rectangle, right? So let's, this is inclusive rectangle helper function, so let's do like a dash line IA1 x64, and let's write a similarly named function for the, actually let's take all of this, right? Let's take all of this and paste it and just change the function names. So we want like a translate, and want to translate on x and y. So tran xy maybe, or just tran maybe. Yeah, we'll just call it tran for translate, and that also means that, oh, well, right here, we forgot to see this zoom 032. We actually have to add that. So U32 and zoom uint32 amount to zoom in and out in pixels. All right, so we think that the rectangular regions are kind of going to go over pixels when they're zooming, so that's the values we're going to use here. So we'll do that there, and then to do man, okay. Okay, so the next thing we want to do is see, we want to get the value, that's good. I guess we can keep this to do here as well, because it's still going to be a problem. And for this kind of stuff here, we just want to take the values instead of doing plus minus, the only difference now is we just want to do this, everything plus, right? And it's not a zoom U32, it's more like a TRA for translate U32. Sure, why not? And then right here, we'll do a U32, and then we'll call it trans U32. Amount to translate in pixels, right? And we have these values. Now we might want to think about, well, what happens if we try to go negative, right? And the way the rectangular region for the camera works is that the camera can never go negative. It can't like be in a negative coordinate space, and that's fine because it's going over data that it's going over a bitmap, right? It's zooming over a bitmap, and all the coordinates on that bitmap are all positive. So that doesn't matter unless you wanted the camera to kind of go off the edge of the world. That would kind of be impossible with all this unsigned integer math. I'm not going to worry too much about that. Now, we do want to worry about accidentally inverting the camera, right? So we might want to take the widths here and do some clamping, right? We might want some type of max-min value on the camera. So let's do something like this. So let's take the width, right? So U32 width equals the x1 minus the x0 plus 1, right? And then the height is a similar formula, right? So the height is going to be the y1, the upper bound, minus the lower bound, and then plus 1 because it's an inclusive rectangle. And we're going to say that I think for now we actually just want to keep the camera square. I think that if the camera isn't square, that's just going to create problems. It's going to like warp things around. Now it's kind of weird that, well, if we have all these extra coordinates, why not make use of it? And I get why, but for now, I think it makes sense to just keep everything square. I think that a non-square camera is just going to look weird, and it's going to create problems for us, so let's just keep everything square, even though it is kind of redundant to kind of like be like, oh, we got an X and a Y, but here we are just enforcing it to be square. So we're going to say that, you know, if the width is not equal to the height, then we're going to call that an error and say error cam not square, and we're going to say zoom pull, right? So we're going to say the camera's not square, and here is the function that it came from, right? And then we're going to take this over here, and we're going to paste it in here as well. Now this is kind of these calculations should probably be kind of like sanity checks at the beginning. So we should probably put them, well, actually, no, we have to actually fetch the values, don't we? So we have to actually do the get, so no, it makes sense here, never mind. And we can do the same thing here. So it's beneath this vital to-do command, so we might as well kind of like put that right there. Also check to make sure that everything's square before we do any edits. So now that we know the width and the height, we can use that information to clamp on here. So we're going to say that, you know, also, you know what, if the, if width is greater than 512, we're also going to say that's a problem for now. Now we can remove these mistakes, or these assertions later, because maybe we decide that we don't want these kind of constraints, but it's good to make more constraints rather than less, and hone in on the design, right? Make the design a little bit more rigid, and that way you can have focus on what your problem is, right? Like, if you're open to all possibilities, that really dilutes your focus. So we're going to just say that the camera, in terms of its size, can only be 512 by 512 pixels, because it's this camera going over this 512 by 512 data set. So that makes sense to me. It might not make sense in the future, but let's just cap it like that and just say error width over 512, and we'll make a note that it came from the zoom pull function, right? And we'll do the same thing for the height, right? So if the height is greater than 512, we'll say that the height is over 512, correct? And yeah, just add a little bit more constraints than we actually need for just because we want to kind of hone in on what we're actually trying to do here. So this is not the zoom pull function, this is the translate function. So we'll take this right here and we'll rename this to tran. And now that we have these sanity checks, we have the translation logic here, and then we have the zooming and pulling logic here. The next thing we need to do is think about, well, what if we kind of keep on... So we have this camera, right? And we're zooming it in, and we're zooming it in, and eventually if it gets small enough, it's going to collapse in on itself and invert. And how are we going to prevent that kind of inversion? So the way we're going to prevent that kind of inversion is we're going to ignore the commands if the camera's already too small, right? So in here, we're going to say that, you know, if the width is... Or actually, if the width and then plus this amount here. So the width... Well, hold on. Let me think about that. So we're assuming that zooming makes the rectangle smaller, right? So it's the width minus however much we're zooming in divided by 2. Oh, but then what happens if we're zooming in by like a single pixel, right? If we're zooming in by a single pixel, we still have to pull in by 1 pixel on each side, so that doesn't matter. We're pulling in by 1 pixel on each side. Okay, so this number is actually the amount on each side we're going to pull in, right? So if we zoom by just 1, it pulls in by 1 pixel on this side, but it also pulls in by 1 pixel on this side, and pulls in 1 pixel this side, 1 pixel this side. So there's no division by 2 we actually have to do. So we just need to see that width minus the zoom U32. We want to make sure that that is greater than or equal to 1, right? So if that's greater than or equal to 1, and we want to do the same kind of clamping on the other side. So we'll say that if 1, and the height minus this zoom pull amount is greater than or equal to 1, then we can actually do this logic. But there's also another thing. If we want to make sure that we're not kind of going out too far. So if we take the width and we are adding the zoom kind of pull amount, then we want to make sure that that is less than or equal to 512, right? And then same thing for the height. So the height plus the zoom pull amount, that needs to be less than or equal to 512, right? So we want to keep these clamps here, right? So if those clamps are, if we're about to make the viewport too big or too large, then we don't do this, right? So, you know, so we can say, you know, we can make a little section here, and we can say, you know, guard from zooming in or out too much, right? That's what this section is. Now, we might want to make this all lowercase, since this is kind of like a section within a section, and I think that lowercase kind of looks a little bit better, right? Because we have these dashes and lowercase to make like a kind of a thinner line, whereas in our main section headers we're using all uppercase, and then we're using equal signs, so it makes kind of a thicker line visually. So I think that we should kind of stick with that, right? Okay, so okay, so we'll take that, and that looks good to me. You know, guard from zooming in or out too much, right? So we need the same kind of guard on our translation, but our translation is a little bit different, right? Because now this width and height, does that actually make sense? Yeah, that makes sense. Now there's some other types of caps we could do to this, right? Because we're not accounting for where the camera actually is, so we might want to have some type of camera readjustment, depending on where the camera X and Y is. So we have a guard, and then we might want to readjust. Camera readjust if hits borders. Back off the borders. Okay, we're going to back off the borders here. We're going to make another section for that logic. So backing off the borders. Like, what if we kind of, like, zoom in the camera, and the camera isn't too large, but the camera is now going outside of the bounds of the world, and the world, we're saying the world is this, like, 512 by 512 thing. So what we need to do is we need to say, well, if any one of these rectangular regions is kind of, like, off the borders, then we need to translate over, right? So what we're going to do is say that, you know, if x0 is less than 0, then we need to fix the lower bounds, and then it's going to be the same math for the y0. So if y0 is less than 0, we're going to do some math. And then for the upper bounds, if x1 is greater than or equal to 512, right? Because it's an inclusive rectangle, so 512 is actually on the border. And now we could do like this. We could do greater than, we could do greater than, instead of greater than or equal to 512, which might be kind of confusing because we have these operators are no longer symmetrical. What we could do is we could say greater than and 512 minus 1, right? And that's and that makes you understand that there's that off by 1 error that we're kind of accounting for. And now we have these same symbols here, right? And that can make that a little bit easier to follow. So let's take that, and then you know, if y1 is less than 512 minus 1, then we'll do this, right? Okay, so so now the next thing we want to do is figure out what that math is, right? So back off lower bound. So this is backing off the lower bound, and right here is backing off the upper bound. Back off upper bound, sorry, back off, it's still lower bound, sorry. This is still the lower bound. Back off lower bound and back off upper bound, right? So let's do back off and then upper bound. Okay. And then say back off upper bound. Okay, so now that we have this kind of set up here, we want to figure out, well, what is what calculations do we need here? Well, we need to figure out what that delta is. We need to figure out, well, how far off are you, and then what's that fix going to be, right? So we can say and also we need to restore these values that we get, right? So after we do all this math, we actually have to put it back, right? So let's actually account for that. So this is, so right here we need to persist, right? We need to put the data back, right? So instead of calling it TAUTYPE get, it's going to be TAUTYPE put. And we don't actually have we don't need the AND symbols around it anymore, right? It's just going to be x0, x1, etc. x0, x1, y0, and y1, right? Okay. And yeah, we're just going to put it so we can write here that restore values to bitmap. We'll say, right? So we're going to restore the values to the bitmap. That's what's going on here. Okay. Ooh, big mistake. Okay, so restore values to bitmap, right? And so yeah, now that we have these here, we need to, what do we need to do? We need to still work on this math here, right? So, if the x0 is less than 0, then we just want to take, well, actually the x0 can't be less than 0, can it? Because they are unsigned values, are they not? If there's no way we can go negative, right? And so when we're shrinking, we actually don't need to worry about this, right? So what we're gonna say is we're gonna take this stuff here. We're just gonna make a note of this, right? Sanity check here. So we just make some notes. Don't need this section, and make some reasons why we don't need this section. One, the first reason we don't need this section is, well, actually, what could happen is, oh yeah, so I'm seeing what happens here. If this goes, okay, you know what we're gonna do? So this math actually is gonna be easier if, right, we have these U32s that we get back, and we need a signed version. We need signed versions of these so that we can, so that some of the math is gonna make a little bit more sense, right? So what we're gonna do is we're gonna say that, I32 and x0, I don't know what we want to call it, x0, we could say x0 and say I32, right? And we could declare that, we might as well kind of declare it after we get it, I guess. That way we can't accidentally pass the wrong thing into this getter. And we'll just assign these to the unsigned versions, right? So we'll kind of upcast, right? Okay. And we can take this here, paste this here, okay? The next thing we want to do is, what do we want to do here? I don't know. I guess what we should probably do is make a explicit cast here. So we're actually going to do I32, int32 cast, right up onto these, and we can actually leave a space. I believe that's valid. So this x0, x1, y0, y1, right? And now when we're doing our math, we can actually, because I'm thinking of some scenarios where things could go pretty wrong here if we're not using the signed values. So let's actually kind of use the signed values now that we have them and kind of mess with them, and then we put them back on the GPU as these unsigned values. So the width, this width is, and also the width, right? Things might go weird if we do the width like greater than or equal to 1, right? The width goes negative and the calculations make no sense. So this should probably also be in 32. And then down here where we're doing the other version of the function, we should probably fix that as well. So these widths and heights, let's make them I32s. And let's take the logic where we are kind of right? A lot of this is going to be very repetitive, but it makes it kind of very easy to follow, right? So we're going to take this logic and we put this, okay, we put it before the to-do manager, so we're going to put this right here. And yeah, we got these int32s, and let's look at this logic right here. So right here we're kind of like doing this logic. We want to take that logic and we want to replace it with the signed versions of the numbers. So we're going to throw that in there like that, and then we're going to throw this in there like that. And then the zoom amount, if you look at the zoom amount, it is a U32 value. And that's fine to keep the zoom amount a U32 value, because it should never be a negative value. Actually, that's a lie. That is a lie, right? Because we're going to use one value to either zoom in or zoom out, right? And if we're going to use one value to zoom in and zoom out, right? Because we said that don't use this, just use zoom pull, right? Just use it with the opposite signed value. Well, if that's the case, then we need to use signed values here. So this actually needs to be at int32, and so that's my bad. And that also means that for the signature for the translation, the amount to translate, well, first of all, we need an x and a y value. So let's, I know we're kind of bouncing back and forth here, so let's do I32 and let's say trans x, or tran, or we could say tran ix, like translate integer x. I don't know, it doesn't really matter. Tran ix and iy. I like it kind of like this. I don't know. It doesn't really matter too much. Amount x-axis, right? So this is x-axis, and then our y-axis is this, right? So y-axis. Okay, so we have these x's and y's, and what else? So x's and y's, and let's take them and add them to where they need to be added. So right here we have this width, and the width is these x values. We should probably make the width, we should probably, if we have the signed values, we should probably do the calculations in the signed versions, right? So take the x's and take the y's. Okay, so x1, the larger minus the smaller, the larger minus the smaller, right? And then plus 1, right? And int32, width, right? That makes sense. So let's find the width and height calculations up here, right? We're kind of like going back and forth and kind of repeating ourselves a lot. But oh well, right? So int32's the width and the height, sure. And for this translation, right, we want to take the integer values, so x0, x1, y0, y1, these guys, we want to take those, and we want to take those, and we want to take the appropriate x or y value, right? So the x's first, we're going to offset the x's, and then we want to offset the y's, so x's and then y's, right? And translation, we're going to assume that we're adding a translation value, so we the default is to assume that these are positive values, and we're translating forward on both of these axes. If we give it a negative, we go in the other direction, right? Now for this, we want some way to make sure that, well, what if we go outside of the bounds, right? And so we need to fix that. But before we fix that, we should probably do the restore values to the bitmap. So we have this thing kind of right here, and it's not written completely correctly. So let's fix that. Restore values to bitmap. So we have this put command, but we have not. We actually don't want to do this directly like this because these haven't been restored yet. These. Right, so this is the int32s, so we want to change this to int32, right? So we're transforming the int values, right? So we're getting the values. So let's say let's call this get or put bitmap BM data. Let's say get or put bitmap variables. So we're going to label it get or put because it's going to make it easier to keep track of the two sections. So we're actually going to call it get or put bitmap variables like this. And let's actually give it a little dash right here like that. And here we're going to do this, get or put bitmap variables. And then down here, we'll say, like, instead of restore, we're going to call it get or put bitmap variables. And the reason for that is it's going to make it a little bit easier to see the complementariness of this, right? Because we're going to do this stuff here, right? We're going to get the variables, right? And then we're going to do the exact same complementary operation on the other side, right? So to restore these, we got to take these cast, right? This cast stuff we were doing, and we got to like swap that around, right? So we got to take these values, and we need to put the int values on here, and we need to do a u32 cast of them, and then assign them, right? Before we can set them, right, we have to persist them, right? And I didn't want this logic to get too complicated, but we gotta make sure we persist those values. So the int32, x0, x1, y0, y1, right? And if these are out of bounds, we're gonna have some trouble, so we want some type of bounds checking as well. We'll kind of figure that out as we go. And now that we have this here, it would be nice to kind of paste these in the corresponding sections here. So, right, so a lot of duplication, but it also gives us time to double check what we've been doing, right? So then up here, we have this get, and then we have these casts. So we want to label that as well. So now if we look at where we have the get or put bitmap variables, we should have 1, 2, 3, 4 sections, right? 4 sections, 1, 2, 3, and 4. So we have these 4 sections, good. And the next thing we want to do is we want to figure out what we're doing. That's what we want to figure out. So we have a guard right here. We have the width and the height, and they're int32s, and we have this zoom u32. And we're making sure that if we subtract... That's not quite correct, is it? Does this bounds check work? So let's say that we're at 1, and we use a positive 1, right? Because we want to... So we use a positive 1 to zoom in, and this is going to bounds check us, right? Now, what about this, though? Does that screw us up? Let's say we are at 1 and width plus the zoom amount. Now, I think this bounds check, even though it's kind of weird, even though some of the comparisons won't make sense in certain cases, I think the bounds check will still catch things, right? So, so the width, right? Because this is how this is going to affect the width, correct? Or is it? So this zoom value is either going to be positive or negative, right? And when it's positive, it's going to make the width. Yeah. So this offset here, where we're doing this plus and minus, I don't think that's the correct thing we want to do. We want to make sure that if the width plus that zoom amount is well, hold on. In our offsets, we are... In our offsets, we're kind of like, we're doing this plus minus thing. The zoom amount, if it's positive, makes the rectangle smaller, right? The zoom amount, if it's positive, makes the rectangle smaller. And that's why we use this minus here. If it's positive, it makes the rectangle smaller. So therefore, we minused it, right? And if it's negative, if the value is negative, then it makes the rectangle larger. If it's negative, it makes the rectangle larger. Interesting. Okay, so actually, it's all this, right? So negative makes... So... So I'll just say neg for all. Okay, so the reason for neg for all here with these bounds checks is because if we input a negative value, then we're trying to pull everything out, right? If we're trying to make a negative value means that we're trying to make the rectangle larger, right? A negative value is a zoom out, right? Because a positive value is zooming in, a negative value is zooming out, right? And if his negative value is making the rectangle larger, then to do the correct bounds check here, we have to flip the sign again, right? So it's a negative value that's inputted, so a negative minus some negative flips that to positive, right? And that's what we want to do because we want to check for the upper bound, right? And if the value is positive, then this check right here, it's this minus this certain positive value. Make sure that it doesn't go beneath 1, right? And now the thing is, well, what if... Does that have any type of bad effects where does this work in all cases, or does it kind of screw us up in some cases? And I don't know. I think that's the correct thing to do. And so we'll take this negative for all, and we'll say we'll go into our documentation here and just write a little comment for that, right? So this commentary here. Okay, so negative for all. All calculations on all lines are negative. Lines use the example. So example, so okay, and then we'll do like a video integer ID and say 0060, and the time is 1 hour 32 minutes and 25 seconds, right? Okay, and the next thing we want to do is let's see. So let's take this video integer ID here, and let's do the same thing where we kind of like made note of it, right? So this kind of neg for all. Let's make a video integer ID, or at, even though I keep on forgetting to at symbol. So eventually I'll get it. So at video integer ID, and it is 0060, and the time is 1 hour 33 minutes and 26 seconds, right? And I thought some comparisons needed to use a plus sign, but turns out all comparisons should be minus for correct bounds checks. Okay, so just a little bit of note of, like, I thought this should have been like plus and minus, but it's not because of the way the math works out. So we can keep that kind of note there, and that way when we're looking at the code, we can kind of hope that we know this kind of corresponds to what's going on here, right? So if the bounds check passes, then we actually do the math, right? And after we zoom in or zoom out, there's the possibility that we need to back off of a lower bound or an upper bound. And in order to back off of a lower or upper bound, right now we're using signed values because we can't do it with unsigned values, right? So we're going to say that the y0 or the x0, right? So the x0 or the y0. And then this same thing here, right? We just want to add the i32 here to make sure that we know it's an int32 type. And from here, I guess we just want to figure out what the backing off of the bounds logic is, right? We want to make sure that if we're on one of those bounds, what do we do to get off of those bounds? So, assuming that the rectangle is not too large, right? Assuming that we correctly guarded here, the only thing we need to do is move the rectangle if it's gone too far in a certain direction, right? So, if it's gone too far on the x direction, we'll say that x0 i32 plus equal, and we'll do, well, actually not plus equal, because what we could do is we can just do the minus equal, right? Like if we do the minus equals, then, and take x0 i32, then, then that'll fix the problem. Now we want to do the x1 first, right? Like if it's x1, if we're affecting ourselves here, we want to do the x1 i32 minus equal, right? We want to zero it out, right? So we'll do the x value first. So x0 i32, right? And now the problem with doing this is there's a lack of symmetry in the code right now, right? Where we have these two zeros here, so there's not a very good symmetry, which I don't quite like. So so I don't know if that's the way we want to do it. It seems kind of error-prone. It is kind of like it is an efficient way, sure, but I don't know if that's a good way to do it. So I think we'll call it i32, and we'll call it delta, and we'll say that delta equals 0 minus x0 i32, right? So we'll take this value, right? That's less than 0 right now, and we'll flip it, right? And then now that we have it flipped, we can do a plus equal, right? So it kind of makes it a little bit more obvious what's going on here, right? So we are taking this rectangle that's gone past that negative boundary, and we're adding to it, right? And we're adding enough to it to get it outside of that negative boundary, right? So the next thing we want to look at is the y boundary. The y boundary math should be exactly the same. Now, do we want to call this like do we want to call this delta x and then call this delta y? That might be a little bit nicer to make the code a little bit complementary. I don't know. Maybe it's just a worst idea. I don't know. It doesn't really matter too much. So this value right here, instead of calling it x0, we want to call this y0 minus 0, right? We're flipping it around, right? So these should match here. And then right here, instead of using x's, we're going to use y's, right? So the next thing we want to do is just make sure does all that math kind of line up. So if we look at the x0s and the x1s and the y0s and the y1s, do we have a similar pattern between both of these? And we do. So then we might want to color the deltas a different color and see, do we have an analogous pattern between both of these bounding logics? And it does look like we have an analogous pattern, so we can kind of continue and go into the next section. So down in the next section here, we need to figure out, well, what's the bounding logic for this? And it's going to be very similar, right? If we're over 512, we got to figure out some type of delta, and then we got to minus it. So we'll take this kind of section of code right here as a template to work with, because it should be very similar to the calculations we do need to do. And the i32, it's greater than or equal to this value here. So we need to figure out, well, how much over 512, over the 511 are we, right? So we're going to take the, we know that the 511 is the smaller of the values, right? So we'll take this, and we will minus 511, right? And we might want to make a note of that, right? Might want to make a note that that's minus 511, right? So we can do like this, at minus 511. And just do that so that we know that, you know, it is 511, not 512. So the idea is that if this were at 511, this would be 511 minus 511, and there would be no problem, right? Because we're not actually over the boundary, and it's 0, right? So when we're looking at to see if the math is off by 1, I would say no, we're not in this case. But we want to do a sanity check of that. So now that we know what the value is, right? So this is a positive value that's off the bounds to the right side, right? It's the upper bounds out of bounds. So we want to bring it in the other direction, right? So we're going to subtract that delta from the x and the both of the x's, right? Because we want to move those x and y boundaries together. So now that we have this, we can take this and we can paste it down here like that. And we have delta x, we got to change that to delta y, and instead of x1, this is y1 anywhere else. So these are also y's, and these are y's as well. Okay, so now that we have that, the next thing we want to do is we want to spot check this math. We want to make absolutely sure that this math is correct. So we got these upper bounds, so let's highlight everything that should be x, right? So everything that should be x, that should be x, and these things are y's, right? I see y's, I see y's, right? And everything that should be x and everything that should be y is highlighted. There's no, like, intermingling here. We have the x's and then the y calculations. X's and the y calculations. So that looks good. Now, the next part is, well, what about the upper and lower bounds? So let's say that we're going to highlight upper and lower now. And we're also going to look over here, upper and lower. And then upper and lower. We're also going to highlight the upper here and the lower here. And we want to make sure that there's the same pattern here as is here, and that looks pretty much correct as well. We might want to say that deltas are kind of a different color because they, you know, it's not quite the same thing. And then we also see that we have the pluses here for when we're going negative, and then when we're going over bounds, we have the minuses, right? Because we want to bring it back the other way. So those calculations look correct to me. Like, I think we're pulling it in correctly. I think we have the correct bounds checks on the camera logic. And, right, and it's guarded. It's guarded to say, you know, the camera, before we even try to push or pull the camera, we want to make sure that it's not going to make it too big or large. If it's going to make it too big or large, we're not actually going to do anything to it at all, right? And that looks good. So the next thing we want to look at is the translation, right? The translation, we don't have any logic for bringing things in, right? So we have these checks, and we have the translations applied here. So the x's and the y's, the zeros, the ones, x's and y's, the zeros, then ones, ix and iy, right? Because these are the x's and these are the y's. So we want to say, well, what if this goes out of bounds? And I see that we have kind of like very similar bounds checking logic, to the point where we wrote all that logic. We shouldn't really have to write it all again, right? And how are we going to do that? Well, we can pass these values by reference to some type of bounds fixer function, right? I think that would be the best way to do it. And so all of this back off the upper bounds, back off the lower bounds, back off the borders, like all of this code could be put into a helper function. So that's what we're going to do. We're going to take this and it's still inclusive rectangle stuff, so we're going to put it in here, and we're going to say void, we're going to say AAC 2020 tau type rec inc, and actually this should be lowercase because it's a private, this is going to be a private function, so AAC 2020 tau type rec inc, and we'll call it bounds fix, or enforce bounds, I guess, maybe. We'll call it enforce bounds, I guess. And, I don't know if that's the best name or not, but that's the name we've chosen, and that's the name we'll go with. And the only reason we're pulling this into its own function is because we, right at this very moment, we know we're going to reuse the function in two different places, right? And because we're going to reuse the function in two different places, we absolutely need to to copy that code, right? I'm not going to extract things into other functions just to make the code easier to understand. I think that's kind of stupid. I think that if we need to actually reuse the code, then that makes sense to put it into a reusable function. That way we don't have to write all this code twice and then have to maintain 2 identical blocks of code. That would be kind of silly. So let's take this stuff right here, and we'll just say, you know, AAC 2020 tau type rec inc and enforce bounds, right? And then we'll get back to here, but we want to paste the code that we're about to write, right? Before we lose it on our clipboard, it would be good to just paste it right into here. And we know that we're using kind of these pointers now, and we might want to think about, well, how are we going to do all this math with them, right? If these are actually pointers now. So there's a few ways we could do it. I think that the easiest way would be to just create a value that says it's a pointer, and then extract the pointers, manipulate the values, and then restore. Extract and restore. I think that would be the easiest way. It would also not require us to rewrite any of this code, right? We can keep the code exactly as it is. So we're going to do int32 pointer, and we're going to call it pointer x0 i32. We could do the pointer on the other side. I don't know how we want to do that. Now, a lot of times I'll do this. I'll do by ref. Yeah, we might want to do by ref or input output argument, right? Input output param, right? And we could label it kind of like really clunky like this, right? And that's not a problem. I don't think that is a bad idea necessarily. As long as we have the column space to like do this, right, and be very obvious about what we're doing, I think that's fine, right? And then right here we can make a section called extract values from pointers. Okay. And then, so right here we'll extract or restore values. Let's say extract or restore values, because we're going to have 2 synonymous chunks, or 2 analogous chunks right here. So right here, let's put this here and extract those values, right? So let's say that, you know, the i32, the x0 i32 is going to be equal to a dereference of these values, right? So dereference. And then we want to paste this a few times, and then we can just take this section right here, and we can paste it right here, and we can paste it right there, right? And so now we have this, and we have this, and we got this, and we got this, and that's not highlighted. None of that stuff is highlighting. Hold on, so let's make absolutely sure that we spelled these correctly, even though we kind of just cut and pasted there, so we should know that they should match, but just want to double check ourselves there. So that looks good to us. And the next thing we want to do is we want to go down all the way here, and we want to restore those values. So we're going to take our input-output parameters, and we're actually going to just flip it on its head, right? So we'll take the input-output parameters and do this. So the idea is that we don't actually want to change the addresses. Like, the addresses brought in, we don't want to change those. And that's kind of why I think it's easier to extract and restore the values. That way we don't have to think about any of the messy pointer logic when we're reasoning about these numbers here, right? So you could think of these references, you know, hash at by ref, right? We could make a note about that. So we could make a note of at by ref and say that this note is to, you know, we want to think about what is being passed into this function as being passed in by reference, right? So so we'll do at and then by ref and say, you know, when you see this, it means you should think of the argument in the function as something being passed in by reference. C does not have references like C++, but references are basically just pointers that are not allowed to be dereferenced. Or, well, they can be dereferenced, they just, well, that's not quite right. They are pointers that cannot be reassigned to a new memory address, right? So that's what that is all about for this by ref thing that we're doing here. So yeah, we're gonna take these input-output parameters, we're gonna unpack them, right? So we're gonna dereference them and get what their actual values are, right? So right now, these are memory addresses. If we want what the memory address actually points to, the value it's pointing to, we got to dereference it, and then we have these values that we can work with, okay? The other way around, if we want to assign the value, we do the same thing, right? Because if we don't use that star operator, then we're changing the address, right? So we have to do the dereference operator in the assignment, okay? So do that, and then we have the restore, right? So we have a backup, we have an extract and restore. So we got these two analogous sections here, right? So now in where we want to call this, right, like right here, we're going to take all of those values that we just manipulated, and we're going to throw them in here, right? And we need to make sure that we actually throw in the pointers, right? So these need to be pointers, and we'll do like an and we'll do it like that, right? So the x0 and the y1, etc., like that, and then we'll do this, right? So we'll do it like this, and okay, so x0, whatever, right? Okay. So now that we've done that, you know, we had this enforce bounds function. That looks pretty nice to me. We're going to take it and we're going to reuse it in the other place that we need it for. So we're in the function that's kind of like zoom polling, and now we need to go into where we're translating. So in this translate function, we can see that, where are we doing the translate? We're doing the translate right here. Yep. So we're doing this translation right here, and you know, we're just going to allow it to translate it anywhere it needs to be, right? So if we translate it out of bounds, that's perfectly fine, because then we're just going to immediately pull it in, right? So we're going to enforce those bounds and pull the values back into where they need to be, right? So here, and then we see these values right here. That looks good. And we got the x's, we got the y's. So with that, that looks like everything that kind of needs to be there, right? And then we want to restore the values, so we're going to cast back to a U32. Now, if we want to be really careful, and I think we should, because we've been burned quite a lot by this, we should just put some asserts and assert that the x0 I32 is greater than or equal to 0, and that the x0 I32 is less than or equal to, you know, 512 minus 1. And then we want to do that for all of them, right? So let's just put in those asserts there, and these are the asserts for the signed versions, right? We want to bounds check the signed versions just to make sure that when we do these casts to unsigned, that we're not completely shooting ourselves in the foot, because that has happened to us lately. So we'll do these asserts here, and then we also want to do the same asserts right here. So we have a lot of, no, not here, but up here. And this is a lot of duplicated code, but it's very simple, right? It makes a lot of sense. It's straightforward. It's not a problem. We know what's going on, and that's the most important part. Now, we do have a lot of stuff here where it's like, man, TAUTYPE is like this huge thing, and if we have any other types, then that's kind of like a big deal, right? But I think that keeping everything related to TAUTYPE kind of in here kind of makes sense to me. Now, do we want to call it inclusive rectangle, or do we want to call it like TAUTYPE rec inc? I don't know. But if we have enough room to where we could do this, we could just do this. TAUTYPE rec inc. And that way, if somebody's looking for TAUTYPE rectangular inclusive, they can kind of find this. And I'm actually going to make another thing. I'm going to say inclusive rectangle, AAC 2020 TAUTYPE and rec inc. And this is just in case you're searching through the code base and you're looking for something you're looking for this specific type that doesn't actually exist, right? This type right here is very conceptual type. It doesn't actually exist. But if you search for it in upper or lowercase, I still want you to be able to find it. So we're going to put like these double thick borders around what we are looking for. And, you know, we're kind of flipping the case in a checker kind of pattern. That's not something I'm thinking about. That's just a effect of me doing this really fast, and I don't really care about it. So, I don't know. I just thought aesthetically it looked kind of nice. Like, I'm kind of just sticking with it. Inclusive rectangle, right? So inclusive rectangle. And now if we highlight these, we just want to make sure those match, right? So now we can traverse back and forth between the different areas of the code we've written for the tau type. So now the next part is, well, we have this kind of like function for tau type, but we need some type of unit test to make sure that these functions actually work properly, right? So we need to back up the data. Okay, then we need to mess around with it, and then we need to restore the data, right? Because these types exist on that texture memory. They don't exist anywhere else, right? They are very tightly coupled to this tau depot object, right? Which is wired to that texture memory, right? So if we want to make a note of what tau depot is doing, we might want to make a note that go into the pixel name kind of thing, and make this a little bit easier for people to kind of follow the data, right? So, because what we're doing is we are putting data onto this, right? So we could say, you know, that, you know, put data into, and then this thing, right? Because that's where we're putting the data. Or we could say at puts here, right? At puts here, because then we can kind of like trace where that's coming from a little bit better, maybe. It'll kind of document itself a little bit better. And then we could do the same thing with the gets, right? So when we're looking at this, we got this AAC 2020 Tau Depot. We could also make a note here, right? So we could paste this here, and instead of puts, we could say gets here, right? And then we could do the same thing on the other functions that we're using. So we'll use a at gets here, and then down here we'll use an at puts here. And that's just going to make it a little bit easier for people when they're reading the comments to be able to trace where that data is coming from. So we're mostly finished with these kind of rectangle functions. So you know what we're going to do is we kind of forgot to make a lot of commentary about this. So what we're going to do is say that I'm going to say at vid iid, and we're going to take the video ID, so it's 0060, and the time is 1 hour, 57 minutes, and 30 seconds. And we're going to say finished first draft of these functions of one. Actually, we have two functions, right? So we might as well kind of like make some notes there. So first draft of zoom poll, and this one's called tran, or translate. And then we had enforce bounds, right? And now I'm noticing that the case is kind of, well, this is capital because it's public, and this is lowercase. So that is correct. I was just making sure that that made sense. And we want to think about, well, where does it make sense to put this commentary? I guess it makes sense to indent it one because it's inside this section. And so let's kind of do that. Let's kind of comment this off here like that. And the next thing is we have a lot of defines that we're missing here. So we have like a define int32. We definitely have a int32. We have a u32. Or do we have a u32? We might not actually have a u32. int32s and u32s. So these are u32s. Yeah, these are u32s. That makes sense. And int32, u32, and u08 are the ones I need, right? And those are the only types that we're using in here, right? And we also have an error message. So let's do define int32, define u32, define u08, And then we need to define ERR, error. And error is going to be AAC 2020 tau type halt. And the thing is with these halt functions is that with the halt function, have we declared it? Yeah, we already declared it up there. That's nice. And now we're just going to take all of these defines and put them down here. But before we do that, we could add a little checksum to how many defines we have, right? So we have 4 defines. So 1, 2, 3, and 4. And we're going to take those and go down to the bottom of this section. So if we go forwards, we should be, because I'm not, whatever, we can go slowly through here, I guess. There we are, that wasn't too much time. And right here, we'll paste the undefs. So we gotta rename it to undef. Undef, 2 spaces, then the things we're undeffing, and then we'll keep the little checksum on the side, so we can, we know that we have the same amount of defines as undef. So we have this rec in zoom push. Is that a artifact of the other stuff? Or yeah, so this zoom push. So this should not exist here. We're kind of duplicating the code there. So let's get rid of that. And because there are more than one function in this section, way I like to kind of denote that there's more than one function in a section is with a dashed line, right? I'm dividing things with those dashed lines, so I might want to put a dashed line here, which looks kind of weird, but it lets me know that, you know, this section, right, is for more than one function, right? And it's important for me to realize that. So we're going to add that. I mean, it does add a little bit more spacing and whatnot, and it adds a little bit more vertical code, but I'm fine with that. Okay, so that looks like a good first draft for the inclusive rectangle type. We might want to add our tests, right? So in here somewhere, we're going to do like a extern for the unit test. So we're going to do extern, and we're going to call it AAC 2020 tau type and unit test. So the unit test is going to be public, and the unit test takes void, and it also returns void. So extern void, and this is just a forward declaration. I usually don't use forward declarations unless they are for a unless they're for a unit test. Unit tests are allowed to use forward declarations. So unit test, and then it doesn't take anything, right? We're going to invoke it right here. So this is the way I do it, just so that we know without a shadow of a doubt. We know without a shadow of a doubt, if we are being consistent, that this function is now below, right? Because we do not need this extern. We don't need a forward declaration if it's above, right? We would only need a forward declaration if it's below. So we're just saying that, you know, the unit tests are at bottom of the file, and we can make a note of that. So at vid video integer ID 0060, and the time is 2 hours 2 minutes and 48 seconds. Unit tests at bottom of file via forward declaration. Let's just say tests, right, to keep that short enough that where it can kind of fit in the allocated space that we have for it. And yeah, just tests at bottom of file via forward declaration. And yeah, we have this kind of space between here and here, which is kind of weird, but because I'm not using any crazy syntax highlighting, and this comment kind of looks the same color as this, to visually parse it, I'm writing it like this, just so I can see the difference. Okay, so the next part is we have to actually write this unit test. So we're going to go all the way down to the bottom of the file, and we're just going to say unit test. Unit test code, unit test, doesn't really matter. I'll just call it unit test. Maybe we shouldn't be too verbose about it. It's just unit test code. The code part would be redundant because it is a test, right? Or it's all code, right? So why say unit test, right? Or why say code when that's kind of redundant, right? So right here, we're going to say that this is, we're going to say void And TAUTYPE unit test, we're going to say void. Or actually, no, we did, we've been doing like U32, and U32 to return stuff if we want to. And we haven't actually been using it, and maybe it's stupid, but it's just the way we've been doing it. And we might as well keep a consistency with the way we're doing it, right? We're reserving like a integer to pass back from the function. We're reserving that for future use. So we're just going to say that, you know, if U32 and then reserved for future use. And this may be, you know, a complete violation of Yagni, and, you know, maybe we shouldn't have done this ever. But this is the way we've been doing it, so we might as well kind of keep to that kind of consistency. So we got the unit test stuff. If eventually we ever wanted our unit test to return a pass or a fail, we would have the ability for that, but we're probably never ever going to do that, just because if the test fails, we want the code to crash as soon as possible. Okay? So, with that, let's write some unit test code. So we have to backup and restore first. So let's, we have some kind of common backup code that we've been doing. And you might want to think about, well, where could we put that common backup code? And I think that the common backup code would probably belong somewhere in, well, before we do that, you know, let's just do a printf to-do, actually, no, we'll do a AAC 2020 to-do manager vital write rectangle tests, right? So we want to write the rectangle tests, and the backup and restore we want to do, right? So we want to do like some type of right here to-do backup data with reusable function, and then to do here restore data with reusable function. The reason we want this reusable function is because we've been doing this awfully a lot, and we might instead of rewriting this very error-prone malloc and free code, if we're going to be doing this quite often, we might as well kind of like put it into some type of reusable function. Now, it might make more sense to like test all of our different TAUTYPE classes at the same time, but then that gets some tight coupling that I really don't want, because remember, when we're talking about how we're compiling, we're going to be able to compile up to any one of these libraries. So we can't have some type of tight coupling where we're going to run tests for all of these in one go, right? But that would be the most efficient way to do it. The most efficient way to do it would be to back up all of the data that is for Tau Depot, and then run all of the tests for all of this stuff, and then restore the data, right? But we can't do that because the way we've decided to do this is each one of these units has to be kind of very self-contained in the way it's coded. So we can't have any type of coupling like that that breaks the fact that we can split this chain anywhere we want, and we're still good. So with that said, the next thing we want to do is, I guess the next thing we want to do is like write the test for this. So let's write a private test. We're gonna say that, you know, the unit test code is here, but this is the public unit test, and we want to call it a private unit test from the public unit test. And the only difference between the private and public unit test is that the private unit test is doesn't do any like backup and restore, right? It doesn't do any backup and restore. So this is the private unit test, and it has it's actually a very different signature, right? Since it's private, we don't have to worry about accommodating that common interface of returning a uint32 and taking a uint32. We can just be like, nope, doesn't take anything, right? So it's void and void, and then the actual logic we want to write is going to go right here. We'll do a dash line I1x64 right here, and then we'll start kind of filling that out. Now, we need to define for a uint32 type, and we're probably going to need all of these defines, I would believe, but let me think about that. We want to test what the data is. You know what? Why not just copy these? Because there's a very high probability that we're going to want to work with all of the same kind of data, because we're testing this stuff, and this stuff uses this data. So it's very likely that we're going to need to use this kind of stuff here. So what we're going to do here is we're going to post this here, and then we're going to just take it, we're going to paste it down here. It already has a checksum, and we can say that undef, right? We want to undef this right here, give it 2 spaces, close it off there, and delete everything in the middle here, and readjust it right like that. Okay, so cool. So the test code, what do we want to test? I don't know exactly how we want to write these tests yet, but you know what I think? I think that we've done the basic rectangle code. So what we should do right now is, before we even write any test code, we should make sure that we're still compiling. And then I think I might want to stop this stream and start another stream, because I think that we have a good chunk of, like, we actually wrote this all the code that we want, and now we're on like a new section where we are writing the tests for it, right? So maybe we should isolate into smaller chunks today. So let's try to do that. We don't have many people viewing anyways, so we can just restart the stream and start it back up and make sure that everything's working. So let's go to our console and give that a run. So let me close this and go to the console, give it a run. And I'm sure that we've made some syntax errors somewhere along the way, because if we didn't, then I would be highly surprised. So error expected, something, something. Okay, so let's go look at that. So that is on line 33, and I don't expect the problem to actually be with that line. It looks like I forgot a semicolon, or alternatively, I put a semicolon where none should have been. So if we look at line 33, we see nothing really suspicious here. Nothing looks wrong here. And that means the problem is probably above here. So if we look above, do we see anything that looks obviously wrong? And I don't actually see anything wrong. We got this extern. So we've done something completely stupid, and I don't know what it is. That kind of sucks. So note an expansion of macro I32. I32 pointer. Oh, it's at, sorry. So the defines kind of give a little bit of indirection. So I'm looking at this line, but it's actually 51. So if we look at 51, and then this will probably be more obvious what the problem is. So int 32, and yeah, the problem is pretty obvious. It's that when we wrote the signatures for this, we didn't even bother with our commas, right? We just aligned everything, and we're like, yeah, we'll get to that later. Was probably the idea for that. And our function calls may also have this problem as well. So we should look for well, not here, but that looks good. What about when we're calling these kind of functions? We have like a get and a put, correct? So, nope, that looks good. The put looks good. How about this function? That function looks good. So yeah, let's give this another run. I think that we solved that problem. Let's see what else we got. Okay, so we got two closing. So yeah, this is just a habit from the way I like to write code, but for my compiler to be pedantic, it does not like me doing that, so I have to get rid of that. And I probably have done it in more places, because it's just a force of habit. Does it? Oh, guess not. So let's try this out. And we have conflicting types for AAC TAUTYPE unit test. So what we're going to do is we're going to take this, we're going to copy it, and we're going to look for, well, where is that? Did we not do this properly? I mean, we have TAUTYPE unit test. Oh, you know what we did? Where we're calling it, we used the wrong signature, right? Because we thought that it was not going to be this. We thought it was going to be void and void, but it turns out that no, it's actually going to take a U32. And what is it going to take for that U32? We're just going to pass it 0. We don't really care what that is. It's just an artifact of the way we thought we should do things, and now we're just kind of stuck doing this for uniformity of the code. Okay, so that looks good to me. Let's get one more run and see if we can get this going. And if we can get it going, we'll stop the stream and start a new one. 2 or more data types in declaration specifiers. U32 void. That doesn't look quite right. U32 TAUTYPE unit test. 2 or more data types in declaration specifiers. I have no clue what that means. I've never seen that one before. So let's just look at where we're calling the unit test. So, oh, I see. We did U32 void. We weren't even thinking there. This is extern U32. We were not thinking when we wrote that. So let's just take this, kind of indent this, and sure, that'll work, right? So forward declaration and then the actual thing. So we can make a note that at vid iid 0060 and the time is what do we got here? Let's see. We got 2 hours 14 minutes. 14 minutes and 49 seconds or 48 seconds. Fixed. Written. Okay, so we made a big mistake there. I don't know if it makes sense to make a commentary about that. But, if we have too much commentary that needs to be removed, I think that is less of a pain than to have not enough commentary. Because you can never add commentary after the fact, after it's been months later, to say, oh, what was I thinking months later? There's no way you can add that. But you can always subtract what you were thinking months later, but not the opposite around. So that looks good. So what we're going to do is we're going to do a git bash here. We're going to do a git status and a git commit-am, and we're going to say that tau type rec inc functions. So those functions are done. Okay, and then git push GitHub, and then we'll also push this up to, since it's working, since the code is actually working, we're going to push it up to the kanji coder one. So we're going to go git push and kanji coder, right? So just kanji coder like that. And then we're going to restart the stream after we take a little break. Since I guess it's Christmas, no one's really watching stuff, so we will kind of, keep it like this. So, yeah. So I'll be back later. I'm going to just archive this, and then we'll be back to do the unit test code for this. And we need to figure out how to reuse the backup and restore logic. So let's go to our agenda screen before we stop here. And we have this tau type rec inc only functions. Tau sync run. So 22. We've kind of done 22, even though it's not very well labeled. But let's go to properties here, and let's go to 22 is 22 is done. And 23 is now going to be tau type unit test. Tau type unit test, and before we do the unit test, the other 23 we need is 23 common backup and restore for tau depot users, or something like that. So I really wish I could make this, hold on, so we're going to cut all this and paste it somewhere so I can edit it a little bit easier. So 23, 24, 25, 26, okay, take that and paste that back in here, okay. And, okay, so now we have our list, 23, 24, 25, and 26. And so, this sprint is taking longer than it should be, right? This should be like one feature, and like we're all over the place, so I feel like we're a little bit too coarse in what we're defining as a sprint. But I think that having, a large goal is good in mind. If you can take, those giant leaps forward, then I think that is good. So next time we're going to do the backup and restore for the Tau Depot users, or the Tau Depot memory. Because we have written this code, we've written this code like twice, so it's kind of cut and pasted in 2 locations. It would make sense to centralize it in, we'd actually need like a tau common for that. So, let's edit this for a second. We're going to say, I'll say like a backup and restore, tau common. So we want to keep everything to 7 letters. So 3 letters is that, com, and then 2 M's would be would be the kind of like, we could say tau com, instead of saying com with two m's, we could say common functions. So tau, 3 letters, conf, and that is 4 letters. So I say tau common like that, common functions, because we're going to need those common functions to be in a different file, because to put them in tau dirty doesn't really make sense, right? Because tau dirty is the first tau file to come, but it doesn't really make sense in tau dirty, right? Because it's used by everything. So we're gonna put that note there, and yeah, tau common stuff is the next thing we're going to work on, right? So we're gonna like insert a new library and work on that common functionality, and then we'll work on the unit test and whatnot. So I'm going to stop streaming now, and I'll back this up, and then we'll get back to it. I don't know how much later, but we'll see. So I'm going to stop streaming now. I will see you in the next one. Thank you.